So this is lesson 3, solving linear and quadratic systems algebraically. Okay, so yesterday we did solving linear and quadratic systems graphically. Today we're going to go over how to do it algebraically. So just a reminder, when we ask for a solution, we're asking where the x and y values for both equations are the same, so where their point of intersection is. And for linear systems of equations, you can either have no solution, one solution, or an infinite number of solutions. But when you have a linear and quadratic system, you either have no solutions, you have one solution, or you have two solutions. Okay, sometimes you end up with no point of intersection. So what we want to do before we actually solve to find the point of intersection is we want to verify using the discriminant that they actually do have points of intersection. So when we use the discriminant, we use our quadratic equation in standard form, ax squared plus bx plus c. Okay, and we substitute a, b, and c into the discriminant. So b squared minus 4ac. If our discriminant is positive, that means we have 2 points of intersection. If our discriminant is 0, that means we have 1 point of intersection. And if our discriminant is negative, that means there are no points of intersection. So we use the discriminant to verify that it's worth actually trying to solve the system of equations. When we solve algebraically, we are not using elimination anymore. We can only use substitution. Okay? So the first thing we do is we isolate the variable in the linear equation. Then we take this and substitute it into the other equation. So either into the quadratic or into a circle, depending on what the question is asking. And then we solve. And when we solve, we end up with our point of intersection. So if we have one point of intersection, we'll end up with one answer, x and y. If we have 2 points of intersection, you should end up with 2 x values and 2 y values. Okay, so we're going to do 3 examples of how to solve these systems algebraically. So the first one, we have a linear equation and a quadratic equation. And we want to substitute our linear equation into our quadratic equation. So if you look here, our second equation is already isolated for y. So I can substitute x plus 4 into the first equation. Okay, so our new equation is going to be x plus 4 equals x squared plus 2. I rearrange it so that it's in a quadratic equation in standard form. Okay, so everything on the same side of the equation. And then we collect like terms and simplify. So our final equation is x squared minus x minus 2. Okay, we're going to use the discriminant to verify that this system has solutions. So we're going to take our values for b, a, and c and substitute them into our discriminant. So my value for b is -1 right here. This is on my second term. Okay, when we substitute it in, make sure you use brackets. My a term is 1 and my c term is -2. So when you simplify this, we end up with 1 plus 8, which is 9. So because my discriminant is positive, that means there are going to be 2 solutions. So now I can actually solve my equation by factoring to find my 2 values for x. So if we look at our equation here, okay, it's trinomial, we want to factor it. So we look for 2 numbers that add to -1 and multiply to -2. So those 2 numbers are -2 and +1. Okay, now that it's factored, we can solve for x. So from this bracket, we can see that x equals 2. And from the second bracket, we can see that x equals -1. So what we need to do now is to find our corresponding y values. So what we're going to do is take x equals 2, okay, and substitute that back into equation number 2. Okay, so instead of x, we're going to sub in 2, so we have y equals 2 plus 4, y equals 6. So our first point of intersection is 2, 6. For our second point of intersection, x equals -1, We substitute that into equation number 2. Okay, so for my second point of intersection, I have -1 and 3. Okay, for our second example, we have a circle as our first equation, and a line as our second equation, and we already have our y value isolated, so when we substitute, we're going to substitute in 4/3x minus 18 into the circle equation. Okay, what we want to do is we want to expand and simplify, collect like terms, and have all of our values on one side of the equation so it is in standard form. So we're just going to expand our brackets. So instead of having 4/3x minus 18 squared, we have two brackets, 4/3x minus 18 and 4/3x minus 18, and we're going to expand them. So we have x squared at the front. Okay, we end up with 16/9x squared minus 24x minus 24x and plus 324 at the end. Okay, so all I've done is I've expanded my brackets. Okay, now we can collect like terms and put all of our terms on the left-hand side here. So if I add together x squared plus 16/9x squared, common denominators, okay, we end up with 25/9x squared. I add together my two x terms, so I have -48x, and I'm going to subtract 100 on the left-hand side, so I end up with plus 224. Okay, so here's my equation in standard form. Before we try and solve this by factoring a quadratic formula, we want to use the discriminant to see if we're going to end up with two solutions, one solution, or no solution. Okay, so we're going to take our a, b, and c values and substitute them into the discriminant. So my b value is -48. My a value is 25/9. And my c value is 224. So if I simplify this, I end up with 2,304. And over here I end up with minus 3,600. This is going to give us -1,296. Okay, so what that means is our discriminant is negative, which means there are no solutions. So there are no points of intersection. So we do not have to do anything else with this equation here. We can leave it in standard form and say there are no solutions for this system of equations. Okay, so all that means is this line doesn't touch that circle. For our last example, we have y equals 2 and y equals -x plus 1 all squared plus 2. So the first equation in this case is a line, right? So y equals 2 is a horizontal line that crosses through y at 2. Okay, and our second equation is our parabola. So I can substitute my first equation into my second equation. So I end up with 2 equals -x plus 1 all squared plus 2. Okay, we want to expand and simplify. So I'm going to expand my bracket here. So I end up with x squared plus 2x plus 1. And I'm bringing the 2 over from the other side. We have to expand this -1 in. So I end up with 0 equals -x squared minus 2x minus 1. And these cancel each other out, so we end up with this as our final equation. Okay, so quickly use the discriminant to determine how many solutions there are going to be. Okay, so b is -2, a is -1, and c is also -1. So we end up with 4 minus 4 equals 0. Okay, so our discriminant is 0, which means we're only going to get one solution. So when I factor this equation, I should be a perfect square trinomial. I should end up with only one equation. Right? So if I'm going to factor this, we'll take out the negative again, so it goes back to a simple trinomial. And if you look at this, two numbers that add to 2 and multiply to 1 are going to be 1 and 1. Which means when I solve it, I only have one x value, which is negative 1. So because the discriminant was 0, we knew that we would end up with only one x value. Okay, so we'll take that x value, and normally we would substitute it back in, but because our first equation here is y equals 2, we know that y is always equal to 2. So we have our point of intersection, negative 1,